Let's do one last example of these. So here's my equation. We still want to find the big four: vertex, axis of symmetry, x-intercepts, and y-intercepts. Now, I want you to practice this one on your own. So notice that this is in standard form, so you're going to want to start with your x-intercepts and your y-intercepts. That's going to be the easiest in standard form. After that, you can move on to finding your vertex form by completing the square, and use that to find your vertex, your axis of symmetry, and then I do want you to graph it right here. So pause the video, try this example out on your own with everything that we've learned, and then come back to see how you did. Let's see how you did. Let's start right here with our x-intercepts and our y-intercept. Y-intercept's easy, just pull out your last number. X-intercepts, if you try to factor this, you'll notice pretty quickly there is nothing that multiplies to 7 and adds to 4. So this does not factor, meaning we need to use our quadratic formula. So I have my quadratic formula here: x equals negative b plus or minus square root of b squared minus 4ac all over 2a. And I plugged my numbers in, so there's 4 is my b, because that's my second number. 1 is my a, because that's my first number. And 7 is my c, because that's the third number. And if I simplify that, I'll notice pretty quickly I get the square root of a negative 12. This is 16 minus 28. Well, we learned earlier before that square root of a negative in the discriminant means that there are no x-intercepts. So I come over here, no x-intercepts. Now, because there are no x-intercepts, that means we cannot use our shortcut for the axis of symmetry being halfway between them. So you do need to complete the square to get vertex form. So here's my standard form. Cut that in half to get my first number. FOIL it all out to get plus 4. I want it to be a plus 7, so I need to add 3 to get them to equal. So plus 3 is my other number. So now I have my vertex form, which means my vertex is at negative 2, 3. Flip that sign, that one stays the same. And your axis of symmetry is at x equals negative 2, the x value of your vertex. So if I graph all that, here's my vertex at negative 2, 3. Here's my axis of symmetry at negative 2. And I took my y-intercept and reflected it across my axis of symmetry to get another point, just to help me graph it and make it look better. So there's that. That is our last example like this. In the next videos, we're going to do a couple applications of quadratics, meaning we'll do some story problems, and then we'll do some kind of weird looking quadratics.